Okay, we're going to find the limit as x approaching 1 plus of x to the 1 over 1 minus x power. And as always, we should just plug in this into all the x to see what we get, right? So when we do that, let's see, we have 1 plus for the base right here. And then we take this raised to the 1 over 1 minus x, I plug in 1 plus for that. And let's see, this right here is 1 plus right here. And this 1 on the top over, and remember, 1 plus is like saying 1.0001, right? It's just a number that's slightly bigger than 1. And if you have 1 minus 1 plus, you actually get 0 minus. Because once again, you get 1 minus 1.001, you get negative 0.001. So you get 0 minus, okay? And this is a negative number. And when you have 1 over 0 minus, this is positive, this is negative, and when you divide, you get negative infinity. So this is 1 plus raised to the negative infinity situation. But this is just, 1 to the infinity indeterminate form. So we have to do more work. But this is not good because we cannot use L'Hopital's rule yet. So this is what we are going to do, right? So here is our usual work. I will begin by saying that you can use L, you can use Y, you can use whatever you want. I will just use L because for limit. Let L equals to the limit x approaching 1 plus x to the 1 over 1 minus x. And what we do is we take the natural log on both sides. So we see this is ln L. That's equal to, this is the same as the following. Ln of the limit is actually the same as limit of the Ln because Ln is a continuous function on the domain. So I can actually say this as the limit as x approaching 1 plus and then Ln of, let me just put on this in red, that x to the 1 over 1 minus x, like this. And what's so good about this? Look at, this is x to this power, and by one of the natural log properties, we can bring the power to the front. Do not minus 1 though, because this is not the power rule for the derivative. This is just the natural log property. So we see that we will have to take the limit as x approaching 1 plus, and I will just write this down as 1 over 1 minus x times ln x now. And of course, you can put this on the top. I will just put this down as the limit as x approaching 1 plus natural log of x over 1 minus x. And now, when we plug in 1 plus into this x, we get ln 1, which is 0. And then 1 minus 1 plus is also 0, but it's technically 0 minus. But more importantly, it's the 0 over 0 form, right? That's the indeterminate form. This is good because we can use L'Hopital's rule. So what we'll do is we'll look at this and differentiate the top and also differentiate the bottom. And then we take the limit. And this is, of course, still x approaching 1 plus. The limit as x approaching 1 plus, and the derivative of ln x is 1 over x. And the derivative of 1 is 0. The derivative of negative x is negative 1. Keep in mind, this has nothing to do with the quotient rule. It's just the derivative of the top and then the derivative of the bottom for the L'Hopital's rule. And in the end, we can just plug in 1 plus into this x. So we have 1 over, pretty much just 1, and over negative 1. So this is 1 over negative 1, you just get negative 1. However though, you see, right here we're saying ln of the answer is equal to negative 1, right? This is not the answer. We're only saying ln of the limit that we're looking for was equal to negative 1. And to get rid of the ln, we do e to this power and e to that power. So they cancel. And in the end, we see that L, which was the original question, namely the limit as x approaching 1 plus of x to the 1 over 1 minus x power. This is equal to e to the negative 1 power. And if you prefer, you can also write this down as 1 over e. Up to you. but I will just box this for you guys, and this right here is it for that question. That's it.